Hello, everybody. Welcome to Space Fest. We are so glad that you are here and that you are joining us today. We're going to give a minute or two for our Zoom room to fill up. We have an exciting, well, that's not the presentation I wanted folks to see. There we go. Whoops, my mouse is real clicky. There we go. All right, welcome. We are so glad you all are here. We'll let folks gather in for just a minute or two. And folks who are just starting to join us, I'm going to mention this in a minute, but if you want to make sure you have some paper, a pencil, maybe a scissors nearby for our hands-on activity, that would be super. And I think we are going to get started now. So, good morning, everyone. We are so glad you could join us for the final presentation of the Bell Museum's 4th annual Space Fest. My name is Holly Meninger, and I'm the Director of Public Engagement and Science Learning here at the Bell, and I'm delighted to be hosting today's virtual event. Our theme for Space Fest 2022 is the future of space exploration. As we look ahead to exciting space missions planned to explore the far reaches of the universe, I'd like to first start by grounding ourselves here on Earth. We recognize that the colonial history of exploration on Earth has harmed Indigenous peoples and exploited natural resources, with legacy effects ongoing today, including here in Minnesota. I would like to specifically acknowledge the Dakota people, Indigenous keepers of the land on which the Bell Museum sits and from which I join you this morning. This land is Dakota land. It was reserved by them in multiple treaties, and it remains sacred to them today. The Bell is a statewide institution, and so I would like to acknowledge the Ojibwe people, traditional keepers of lands to the north. Dakota and Ojibwe knowledge systems are crucial ways of knowing this place now called Minnesota, and we at the Bell honor that knowledge, the values embedded in it, and the people who keep it. And so, with our feet rooted here on Earth and our eyes gazing out towards the moon and Mars, I'm excited to welcome our special guests today, 3 of our regional NASA Solar System ambassadors, Mick, Dee McLellan, and Nadia Abuisnaineh. The NASA Solar System Ambassadors Program is a public engagement effort that works with motivated volunteers across the nation to communicate the science and excitement of NASA's space exploration missions and their discoveries with the people in their communities. Chris will focus on the Mars Perseverance mission, and then Dee will lead us through some fun Mars-themed hands-on activities. You may have noticed on my intro slide a picture of the sky crane with the lander, and Dee tells me that we're going to be talking about that today. Again, if you'd like to follow along, we recommend that you grab some paper, a scissors, and have a pencil handy for that. Finally, Nadia will talk about the Artemis mission, NASA's plans for the return to the moon. Following each presentation, we'll take a moment for a few audience questions, and then we'll bring the whole group together for a conversation and questions at the end. So please use the Q&A box to ask your questions throughout today's program. You may have also noticed that we are live captioning our event today. If you find that distracting, you can hide it by clicking on the live transcript CC button at the bottom of your Zoom screen. All right, first up today will be Mick to speak about the Mars Perseverance mission. Chris runs the STEM educational nonprofit Space St. Croix in Hudson, Wisconsin. He has been a NASA Solar System ambassador since 2017 and is also an aerospace education member of the Civil Air Patrol. Take it away, Chris.
Hey, good morning, everybody. Again, my name is Christopher Mick, and I'm going to share some slides here to kind of get through as quick as I can to give you an overview of the mission if you're not familiar with it, and then to kind of give you a status on where things are today with the mission. So let me get these slides going in a larger, there we go. So if you can see that graphic, this is a artist depiction of the unfurled rover in action. So one thing I wanted to point out that'll pertain to some of the slides following is there were cameras all over the lander and on the aeroshell and on the sky cranes. So we got some pretty amazing views of the entry, descent, and landing, as it's called. It's the upper Mars atmosphere down to the surface. So these are an indication of some of the cameras that are in use by the rover now, and where some of the cameras are located that help with different elements of the mission, from driving to doing some of the science. So I wanted to share that one with you. And then this is what the mission looked like for a great deal after liftoff. This is called the cruise stage. So the rover is kind of packed up here behind the solar panel that you see. This is an artist depiction of its journey from the Earth to Mars. And for a bulk of that journey, this is what it looked like. So it was deriving solar power to keep the batteries charged and to allow for communications to check on the health of the rover on its journey. And then there's an aeroshell here, and then a heat shield on the side that's facing to Mars, which will be needed for the entry, descent, and landing portion of the mission. And then this is what that looks like, kind of a profile view, everything packed in together there. So on the top, you see that cruise stage that had the solar panels on top. That's over the back shell, which provides aerodynamic and thermal protection to the rover. Then you have the descent stage, which I know we'll be talking about later for an activity, also called the sky crane, which lowered the rover, which is folded up here, and then the heat shield to protect it on the entry to the Mars atmosphere. And then I was lucky enough to go to the Jet Propulsion Laboratory when they were finishing assembling and packing up the rover to ship out to the Kennedy Space Center in Florida. So this is a picture where I got to go to the spacecraft assembly area. So there's a big glass wall behind me, very clean environment for all the engineers working on assembling and putting together the rover. So yeah, this photo was taken in 2019. It was launched July 30th, 2020. And then August through February, it was in that cruise stage that we just showed. And then the landing on Mars happened last year, February 18th, 2021. So we're coming up on a year anniversary of Perseverance being on the surface. And then this is that artist depiction of that profile of you. That first image I showed, you were kind of seeing that's the cruise stage, the ending of that. And this is where it's starting to hit the upper atmosphere of Mars. And then all the things that have to happen. And what was amazing about this mission is all these things have to happen controlled by the rover. The light distance communication time between the Earth and Mars is so great that we can't be sending commands every couple of minutes on what to do next for the rover. So it has to have its onboard AI and its computer systems to make these decisions, to react to things that are happening, and to safely bring the rover in for landing. So I know this will be talked about more later, but you can kind of see with the heat shield protecting it, dropping the heat shield, the parachute deploying. Then when the heat shield is deployed, the radar can be turned on. That can be bouncing signals from the ground back up to the rover so it can see if it's getting too close to a mountain or rocky area, kind of read the terrain. And then it jettisons the parachute. After that's done its job slowing it down. But that doesn't slow it down enough. It's still going a few hundred miles per hour because the Mars atmosphere is so thin. So the parachute can't do the entire job alone. So as that sequence of the mission is done, then the sky crane kicks in with these rockets firing that you can see, and that brings it in for the final descent. And there's a unique profile to that sky crane in that we can't just come all the way into the surface using the rockets, because the engineers are worried about all the dust and rocks that could be kicked up by all that force and damage the rover underneath. So what you're seeing there at the end is that kind of sky crane move where it lowers it on a cable the last few meters to safely descend to the surface. And then those cameras I showed on the first slide, this is a real camera shot. This is a shot pointing up at the parachute from the sky crane. So you're seeing that's the sun as it looks on Mars, and you're seeing the parachute fully deployed and bringing it in for a landing. So that's something we'd never seen before, because Perseverance's twin sister, the Curiosity rover, did not have cameras mounted on it for the EDL part of the mission. This is another artist depiction of that final phase I talked about, where you can kind of see the rocket staying away from the ground because they're lowering it on these cables, and then it has a sensor when it makes contact with the ground, and it can fire this guillotine, big sharp knife that'll cut all those cables you see and allow the rover to be safely free of the sky crane on the surface. And then this is a real picture again. This is from the sky crane looking down at the rover, and you might be able to see the dust of Mars being kicked around by those rockets and these cables that are attached to the rover, lowering it down, and the wheels are deploying for the rover. And then this is the reverse shot. This one was one of my favorite images of EDL. This is from the rover, on the deck of the rover, looking up at the sky crane. And so this is right before those guillotines cut the cables, and you're seeing the crane lowering it to the ground. And then this is how they did on the landing. So this ellipse area is where the mission planners were hoping to land, inside a Jezero crater in this blue circle you see. And as a lot of you are familiar with GPS navigation instructions, this is kind of a "you are here" dot on where the rover actually landed. So they almost hit it dead center. So a very successful landing. And then this is a selfie that the rover took. So this is Perseverance with Ingenuity. If you can see where I'm circling here, that's the small Ingenuity helicopter that was mounted underneath the rover. And so this is right after it dropped off and deployed the helicopter and then drove away to do a visual inspection. So you can see its cameras on its mast there, Z cameras facing it to get some images. And then this is a little bit more on the helicopter. So this is what the helicopter looks like on the surface. This is actually an animation showing some of the real images that the rover takes to navigate the terrain as it's flying. So you're seeing views of Mars from the helicopter in flight. And then this is where the helicopter was mounted underneath the rover. So after it turned on its instruments and started to drive away, there's what's called a belly pan, which was dropped. This is for where the sampling cache of tubes is located to leave samples, which we'll talk about, to drop off on the surface for a future retrieval mission. And then this encasement is where the helicopter was located. For a size reference, these are a couple of JPL engineers standing along with the collection of rovers that we've sent to date to Mars. So we started with Sojourner, which is this small rover right here, which was kind of a demonstration mission to see if a rover would work on Mars. And then we moved up to twin rovers, Opportunity and Spirit, which are this profile of rover, a little bit larger. And then we moved up to, this is the Curiosity Perseverance category of rovers. We're getting into a couple of ton, like a small car size rover. So you can see the kind of progression as we've been getting more science on them, larger rovers that can do more. And then this is a scale reference for how big the helicopter is. A lot of people ask exactly how large is it? It's hard to tell from some of the pictures when you just see it by itself on Mars, but it has these two counter rotating carbon fiber blades. Some people that play tennis, you might have a carbon fiber tennis racket. So that's the same lightweight, really strong material that's used to make the blades. And then there's a very thin, you can barely see it here, a solar panel that provides the power to charge the batteries. And then those cameras and batteries are in this box that's shielded and insulated to keep warm on the cold Mars environment. And then the landing legs for the helicopter. And then these are just some fast facts that I pulled. These are all accurate as of February 1st. So I just kind of updated them. So I won't go through all these line by line. You can kind of see on the left side, Ingenuity, fast facts, 18 flights, I will note, is way more than was expected by the planners. They were hoping for a total of 5 flights. This was a technology demonstration. It wasn't a lifelong project for the mission, for the duration of the rover mission. It was kind of to demonstrate that we could fly and control a helicopter, and that might be able to provide valuable science and insight and scale up and make even larger helicopters to be included on future missions. So it's still flying as of today. It's done 18 flights to date. They've gone faster and longer and higher than they thought in the original specs, and the helicopter is in good health. So that's been an amazing, happy surprise that's continuing on with the science part of the mission. So that's some of the stats in the helicopter, and then some of the stats for the rover. Again, we're coming up on almost a year for being on the surface, and driven almost 2 miles so far on the surface, all the kind of stats for that. And then these are the sample tubes. I talked a little bit about that belly pan being dropped. So that's a key part of the mission, is acquiring these rock and soil samples to be preserved for a future mission, sample return mission, 2026. They're planning on sending to recover these sample tubes. This is what a tube looks like. It's collecting about a sidewalk chalk size piece of sample, putting it in this tube and sealing it. And then this is a real picture of a drill hole that it did on a rock that the scientists said that they wanted to get a sample from. And then this is an example of what that sample would look like. inside the tube and then sealed to preserve the atmosphere and the environment to keep it from getting contaminated. And then for retrieval, it would go in a canister like this, is what would be storing all those samples, bringing them back to Earth. It's also got a laser on board the rovers. This is an example of a drill hole made in soil. And then if you see these little pits, those are made by the laser. So they can do spectroscopy, hit it with a laser, and then get a greater readout on what's clays and minerals, and if there's organics and things that are present in that soil. And then these are some of the science goals that are on the missions. There's a weather station. We can hear the wind and get the air pressure and the temperature. The spectrometers, as I just talked about. The Mastcam Z is the zoom camera that's on the head of the rover there that can get really amazing detailed images. We have a subsurface radar on the rover, which means that it can map underneath the rover. It can penetrate the ground the rover's driving over to get an indication of the structures and things that are happening underneath the ground. It's got an experiment called MOXIE that is manufacturing oxygen from the Mars atmosphere, which would be very beneficial to future crewed missions going there. And then the X-ray fluorescence. And then here's some artist concepts on what that mission will look like to retrieve those Mars sample tubes. So it's the Mars sample return mission. We're doing it in partnership with the European Space Agency. And this is what parts of it would look like. So it has a lander that's going to have a small fetch rover, nowhere near as big as Perseverance, because it only has one main job, to go pick up those sample tubes. And it drives down this ramp. It will collect those sample tubes and bring them back. And then this is where that canister I showed you would be installed. All the samples are collected in that. And then it is rocket launched off of the surface of Mars, which has never been done before. And then an orbiter, it would meet that sample, that rocket that's delivering that sample back up, encapsulate that, and then bring that back to Earth. So a lot of different components to the mission, very complicated. And they're right now they're going through all the design test phases for that. And this is again what we hope to get back on Earth from that mission would be a container filled with all of these sample tubes, which would give us these areas of Mars that people have wanted to be able to study in greater detail than the science instruments that are on board the rover. So a lot of information. There's a lot of great stuff out there I didn't even have time to talk about, but that's why there's this website here. If you want to check out, this is the official NASA site for the mission. So all the audio files and the photos and the helicopter videos, they post all those up on there, and you can follow along with where the mission is and the science is being returned from it. And then if there were any questions that I wasn't able to get to today, there's my email below. If you want to shoot me those additional questions, I'll be happy to try to either get the answer for you or follow up with you as soon as I can. Thank you so much.
Awesome. Thank you, Chris. I hope everyone at home is given a round of applause. And we just posted a link to the mars.nasa.gov/Mars 2020 in the chat. So our audience can see that. This is me encouraging you, audience members, to get those questions into the Q&A. We'll have more of an opportunity to ask those questions, to discuss some of those questions at the end. But in the meantime, while y'all are being shy, I'm going to ask some questions because I have them. And I'm the host, so I get to.
Yeah, there you go.
Chris, when is the sample return mission supposed to happen? Like how far in the what? It sounds very complex, and that there's a lot of planning and a lot of players involved. When do they expect it to take place?
It's being aimed for in the 2026 time frame. So it's dependent on, obviously, as you mentioned, all these different parts have to come together. And it's not just NASA. We're working with the European Space Agency. So, for example, they're making the orbiter craft that's going to catch this sample and do that. Jet Propulsion Laboratory, again, is working on the rocket and the lander and the fetch rover and doing that. So there's all these moving parts. It needs funding, obviously, and everything to kind of be making all these development hurdles, but that's what they're shooting for. So hopefully in that 2026 time frame, we're getting another mission launching to Mars to go get those samples.
Awesome. So not too far ahead.
Yeah.
We have Daniel asks, what are they looking for in those rock and soil samples that they're taking?
Oh, a very good question. They're looking for the reason. I should back up. The reason they chose that landing site is because they know millions of years ago that was flooded with water. They have evidence of alluvial fans. You may see that even in your community where kind of a dry lake bed or creek bed, and you see all little pebbles and dirt. You can see where it's kind of pushed out by the rainwater or things. They've seen that in that area. And so they know it was once saturated with water. And they know that there's organics and clays and minerals, there that might have been able to, millions of years ago, harbor microbial bacterial life, that we might find in a river, in our area, in a lake. So they're finding interesting samples that they know have evidence that were buried underwater, rocks and soil. And so they're drilling things that look interesting to them, that they would like to do that further scientific rigor they can do here in a big lab. They can't fit on board the rover. So there's a lot they can do. They can x-ray it, they can weigh it, they can photograph it. As I said before, they can hit it with a laser and see what's made up of. But there's more things they could do back here on Earth. So they want to bring back those samples to see, do they find any definitive evidence that it contains fossilized, microbes or bacteria, things like that. And they would probably be able to definitively say that if they get those back here to Earth.
Awesome. We'll do one more question.
Sure.
I think Andrzej wanted to know, for how long does the reactor battery work in the rover? So how long does it have juice?
Very good. Yeah, it's a radioscopic thermoelectric generator. They call it an RTG for short. And they're on the Curiosity on the Perseverance rover. So the prime mission for the rover is 2 Earth years, 1 Mars year. But as we've seen, Curiosity is coming up on 10 years and it's still going. So the prime mission is 2 Earth years. It should last for several years after that. So it depends. There's not a hard answer because it depends on how many instruments are being used, how much power is it consuming, how much is it driving every year, and that because that changes how much power is drawn from the battery. But I would say if the wheels stay healthy and it's doing good, we're looking at a 10-year plus mission.
Yeah, and I'll let our audience know too that Stacy Tiedekin from NASA Goddard Space Flight Center yesterday talked a little bit about the Curiosity mission, and we recorded that presentation.
Right.
So folks can check out and learn more about the Curiosity mission. And she was referencing that 10 years it's been working hard.
Yeah.
So we still have lots more questions coming in, which means we will have great fodder for conversation later. So thank you, Chris, for an awesome presentation. And next up, we're going to have Dee McLellan. Dee is a University of Minnesota graduate in education. Go Gophers. She has been a teacher for 40 years in math, earth science, and STEM education. She was the observatory coordinator at Jackson Middle School in Champlin for 4 years, and now does professional development for teachers in STEM education with Jason Learning. Dee has been a NASA JPL Solar System Ambassador Master Teacher since 1999 and has been a valued partner and frequent special guest for Bell Public Science events and summer camps. And so Dee, we are grateful you are here. Take it away.
All right. I am so happy to be here. And I love to have you all think about activities and try them, because we need all of you, young or old, to help us think of these great missions and what to do. So I want you to think like an engineer today, and whether it's going to be using this someday for a future mission, or to just use it somewhere else here on Earth for the technology that we can use in our daily lives. That would be something neat. So I'm going to talk about an activity that you can work on at home and with simple things that you probably have around the house. And then for landing on Mars, we saw that really interesting sky crane that we just heard about. And wow, cool pictures back from that sky crane. That was quite a thing that had to be done. The spacecraft had to do that all by itself. It had to be pre-programmed. We could not help from Earth. So here's a fun activity. I'm going to share my screen and show you with my document camera some pieces or materials, and then share a little video on how to try out building your own sky crane and try to land on your own target, which today we'll just have a picture of Mars. And then after that activity, I'm going to show you a little activity you can do to try a little helicopter at home, because what a feat. Landing a helicopter on Mars and having the first powered flight on any planet other than the planet Earth. So what an exciting thing that we've been able to have in this last year, and how many wonderful flights that helicopter has made, and paving the future, just like the Wright brothers, for future flights on Mars with maybe other designs. So let me share my camera with you, and we will build a sky crane to start with. All right, so here I actually have the Curiosity. We had both Perseverance and Curiosity have this landing sequence, and then finishing with this sky crane here. So we went through the sequence of coming in and needing to slow down, and then the parachute deploying and slowing it down more. And then finally, the sky crane hovering over the surface and lowering down the rover on some cables, and then cutting the cables, and it had to fly away because once this ran out of power, we don't want it to fall on top of the rover. So we have to have it fly away after it did its job. And the fun thing was Curiosity, you got to see some Perseverance landing photos, but Curiosity, when it landed, they caught some photos from the orbiter going around Mars. So this is the parachute with Curiosity landing, and the place where it landed. This is actually the test of that parachute inside of the wind tunnel here on Earth. And they can't test that whole sequence on Earth because we don't have the same atmosphere as Mars. So our goal today is going to be to land our little either Perseverance or our Curiosity on Mars. And we're going to go ahead and use some props to do that, and a little setup. So to start with, I have my little model here, but we don't have to use a model. We can just use substitute, and I'm going to substitute with some nuts and bolts for our lander. And I'm going to take a straw. These are just things you should be able to find around the house. And I will just take this straw and cut off a piece of it, get rid of the foldy part, or you can leave it long. Now, remember, you get to decide when you build yours how you want to do it, because this is an engineering project. All right, so then I have one thing we love to do in Minnesota is we have 10,000 lakes or maybe more. And so we like to go fishing. So many of you probably have this fishing line at home. So I find this works really well, but you can use any kind of string that you would be able to feed your little straw through that string or onto that fishing line. Okay, so we would be feeding this on. Now I'm not going to feed this one on because we want to work with this little straw before we feed it on. And I have already made my improvements here. So what I have is my straw, and then I have my bolts here. So, this is like a cooking show. I made it ahead of time. And then on this straw, I have wound a string. And what I do is I measure the length of the string from where I'm going to hang the fishing line all the way to the floor, because then I'm going to wind this up, and this is going to be my sky crane. And then now we would feed my little string on the fishing line so that it's ready to be deployed. Of course, we need some propulsion here. So I'm going to set this up between two chairs in my house or wherever you want to do that. And then I'm going to get some propulsion just using a balloon. And I personally not really into blowing up balloons anymore. So I use a little pump, and we're going to pump up that balloon, and you decide how far, and then just keep it pinched off. And we're going to tape it right to this little system here, and then let that go. And hopefully we've done our job correctly and made our calculations, so it will land on Mars. So let me show you what that looks like, the big picture. I had my grandson and two grandsons and a granddaughter over, and we set this up. And they landed actually on the same day, February last year, as Mars was landing. They practiced and landed their own Perseverance on Mars. All right, I'll hold for a minute and make sure you're all being able to see that. Let me move it a little bit here. All right, and now we will sit back and watch. You can see the balloon here. You can see he's holding on to that, and it's actually on this string. The reason we have some flags here is because you know how fishing line is. If you walk around, you might not see it. So we have some flags to show where it is. This is my grandson, Ethan. I've got Jesse sitting over here and Violet, and they are going to watch and count down for our landing on Mars. So here we go. It's our launch of Perseverance.
3, 2, 1, launch.
Oh no, it's February 18th.
Yes, I did that.
All right, that was a beautiful launch and landing. Now, one question, did we do that on the first time? The answer is no. So there's many things that have to happen there. You have to get the right amount of air in the balloon. You have to get your weight going correctly. You have to have the deployment work too. So that was our final landing, and exciting for us to actually land on our Mars, image there. All right, now, once we landed last year on Mars, as we just heard in the presentation, we brought with us a little helicopter. And again, this was going to be an engineering mission, which it was, to see if we could do it. Can we fly on Mars? Now, something about Mars, the atmosphere there is an atmosphere, but it is less than 1% of the Earth's atmosphere, which means, little example, if we're having 100-mile-an-hour wind, on Earth, wow, we'd be like taking shelter, and our hair would be just blowing everywhere. On Mars, it would probably not even move your hair. 100-mile-an-hour wind, and you go like, what? Well, that's because the air is so thin. There's just not as many molecules in the air. So that is a big challenge, because to lift the helicopter up off of the ground, we have to have some kind of action reaction going on with the blades and the interaction with the air. And then besides that, we have a difference of gravity on Mars. So on Mars, I have my little models back here. I have the Earth and Mars and the Moon. And you can see Mars is much smaller than the Earth. It's about half the circumference of the, diameter of the Earth is Mars. And so therefore, we have to test something again on Earth that we are not sure is going to work on Mars. So the only way we can know is to build it, send it, and try it. So today I'm going to show you again, I'm going to switch to my dock camera. So let me do that. And I am going to show you a little way to build a helicopter. Now, this is a little template you could download if you'd like to, by just, you can find this by just searching for helicopter activity on Mars. All right, but I'm going to show you how to do this. You don't have to use a template. You can just take out a sheet of paper, and you might have one handy. So if you've got that sheet of paper handy, why don't you go ahead and grab that? Now, I'm just going to show you the template to give you an idea of what we're going to do here. We are going to cut out a rectangle, or I actually am going to make it a little bigger than the template here. And so I have started my work here. So here I've got it pretty much cut out. And then for this one, we just are going to cut on those dotted lines, do some folding on the solid lines, and we get a little helicopter. All right, now I'm going to show you how to do that without having to have the actual model. So take your sheet of paper and just fold it in half the long way. I think we call this the hot dog fold. You know, I've been in education a long time, and guess what? My students are the ones that tell me these names. So this is how you're going to fold it. And then take your scissor and go ahead and just cut it in half, which again, like I said, the cooking show, I've done that for you right here. All right, now when you get this half of the long half of the sheet of paper, just fold it the other way. All right, and don't cut on that. That's just going to be a little guide for us. Now, as you remember in our little template here, we're going to not cut down to the middle. We're just going to cut down to just a little bit above that middle. So I'm going to go ahead and take my scissor here. All right, and cut down somewhat, not too close to that middle. We want to leave a little bit of space. And then at the bottom part, you notice there was 2 cuts right on that line, but not to the middle. So a little bit, like I'd say 1/3 in this side, and then 1/3 in this side. All right, now when I fold my little blades here, I don't want to fold them straight down. I'm just going to fold them at a bit of an angle. And I fold one this way, flip it over, and I'm going to fold that one. And when I flipped it over, it's going the same way, but it's actually in the opposite direction. So as you can see, they're both folded, one forwards, one backwards in that little bit of an angle. So this looks like a little house here. All right, now what do I do at the bottom? Well, I fold in the one side to the middle, or actually just in as far as I cut, and then the other side. So now, and then finally at the bottom, I just fold this back up like this. Reason we want to do that is we want to just we want to close this up and not have any air kind of trying to get in there. And that's my helicopter. All right, now what I'm going to do here is I'm going to move my camera, and we're going to try to land our helicopter down on Mars. Oh, and I do have a picture. You did see that earlier, but here's our little helicopter called Ingenuity. What a fun name, right? And we have Perseverance here. And this is an environment on Mars. So I'm going to actually scoot our camera to the edge of my table. And we're going to put Mars down here on the floor. And then I'm going to go ahead and deploy my helicopter here. And you can see that it doesn't just fall to the floor like a thump. Here's my one with the pattern, but it gently spins to the ground. All right. Now, if I did not have the helicopter pattern there, if I just had a piece of paper, you see we would not have the same kind of effect. In fact, one thing you can do is take your helicopter and your paper and put them higher maybe than I'm doing here in the sky, and just see how that works with the blades and the paper, what falls first. And of course, it's always that lump of paper. So this is a fun activity, and then you're not done. Now what you do is you take your creation, your building, your model that you built. And of course, this model is the one I told you how to build. But now you can maybe redesign. Maybe you want to fold the blades a little differently and see what that does. Release it with a little different design. You maybe would fold the blades in a pattern like this, or you might want to shorten this base part, or may shorten it or lengthen it or spread it out in a different way. And this is what NASA researchers and scientists do. They continually work on their model, and they build them, and then they test them and continue to redesign them. So those are a couple activities that you can try at home. And if you didn't take notes, I'm sure you can come back and see our recording and be able to follow the instructions and try these out with your variations at home. All right, I'm going to hand it off to you, Holly.
All right. Thank you, Dee. That was so fun. And I hope folks are able to try this at home and test it. And we would love to see your pictures and videos. So too, please make sure that if you do want to share those on social media, that you tag us at Bell Museum across all the social media platforms. We would love to see your tests. We have an audience question, Dee, but I also have one too. When you were talking about particularly about the sky crane and the helicopter and NASA engineers needing to test it, how did they test those designs here on Earth with very different gravity, with very different atmospheric conditions? What did those tests look like?
Yes, that is something that's very difficult to do. Now, the helicopter was actually, you saw that it was not huge. It was small enough that they could put it into a vacuum chamber. And instead of making it a vacuum, they would actually put in the type of air that we have measured on Mars. And then also they connected a bit of a cable to it. And you know what? I don't know all the technology that they used there, but they actually simulated the gravity on Mars too. So they could do that test inside a chamber. But to land the rover on Mars, to have the parachute deploy, to have the sky crane deploy, to have it go ahead and bring the rover to the ground, that cannot be tested on Earth because we don't have a vacuum chamber big enough to test all those things coming in at that speed and then slowing down to zero. So what they had to do was test each individual part of that landing sequence and then be very confident. In fact, I asked the engineers, I said, when they landed with Curiosity, the whole sequence had never been tested before together. And I said, how confident are you? And they said, we're very confident. And then of course, we all watched and held our breath because we're not even in communication with the spacecraft till it has landed and sends a signal back that we are here, we have landed. And then we know the whole sequence went correctly. And what a wonderful thing with Perseverance, we got all those images back to see what was happening at each of those sequences, because as we design future missions, all of that so good of information, just like I did with the helicopter today, you maybe want to videotape it and watch what happens. And so you can adjust things so that they won't be a problem. I know that when they did get ready for Curiosity, I actually got to talk to one of the engineers and they were testing that part where they cut the cable and the sky crane flies away. And during testing, they did not like how the bolts flew off. They said something could happen there. It could get into the machinery or whatever. So they actually went back to square one, not quite square one, but back and had to retest that and actually delayed their launch of that spacecraft. So they have to check every little part and then be very confident that's going to all work together. But that's why we have tests. That's what we're doing with the helicopter too right now. Engineering tests on Mars.
On Mars. Awesome. That's great. And folks should know that we put the link to the template for the Mars helicopter online. So if you want to download it, but thank you, Dee, for those DIY instructions for those who might not have a printer at home. That's helpful. One last question from an audience member. What happened to the sky crane? It flies off. Where does it go?
And wow, I even asked that question to the person who was the designer, the lead designer of the sky crane. And he said, they have no respect for my sky crane because after it does its mission, it flies off. It actually sends those a boost of energy through the rockets and flies off and crashes. And that's its end of its job. So it's really hard to put lots of things on this. You got to keep the weight down. Everything has to be absolutely necessary to go. So they don't have another parachute for it to gently land or anything like that. So maybe in the future, they'll have something that does do that. But at this point, it flies off and crashes. No respect for the sky crane.
And it does such an important job, but
Yes.
understandable. Awesome. Well, audience members too, please keep those questions coming in because we will have Chris and Dee and Nadia all together at the end of our time together. So last but not least, we have Nadia Abuisnaineh. Nadia joined the NASA Solar System Ambassador Program in 2019, but her love for space and space exploration has been around since she was a little kid. Born and raised in Minnesota, she graduated with a BS in astrophysics at the University of Minnesota in 2011. Woo woo, another gopher, and lives in Mounds with her husband and 3 kids. Recently, Nadia was recognized as a Muslim Shero of Minnesota for her work sharing her love of the night sky with diverse audiences. And we are delighted to have you with us today, Nadia.
Thank
The
you for
floor is
having
yours.
me. Thank you. Hello, everybody. I will be, let's do this, sharing my screen here. Okay, I'm so excited to be here to talk about really something that's just happening right now as we're speaking, which is preparing to going back to the moon. And so this is the NASA's Artemis missions. It's happening, and let's, yeah. So basically 50 years ago, we did the Apollo program, and we landed the first humans on the moon. There were 11 missions, 4 test flights, 6 moon landings, and 12 men walked on the moon. That was 50 years ago, and we've done multiple programs. NASA's done multiple programs since then, but I think everybody's ready to go back, right? So look at these pictures just to remind you of what it looked like the last time humans walked on the moon. Sooner rather than later, we'll be seeing a lot more of these pictures, and in just a different setting, different place on the moon. So this is what it was in the past, and it's exciting to know that it's going to be something in the near future.
50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis, goddess of the moon.
We are returning to the moon
As a new generation of explorers, this time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we would discover life-saving,
Earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
we go for all of America.
We go. We go as the Artemis generation.
We go.
And there you have it, the famous NASA little clips that really inspire for their next missions. And so, yeah, like they said, Artemis is the twin sister of Apollo in the Greek mythology. And it's just so symbolic because really the goal of NASA is to land the first woman and the first person of color on the moon. So this is such an exciting time to be part of this generation, to be something so exciting to look forward to as just a human being, as a woman, and as a person of color. So we're really excited for that to happen. Why the moon? It only makes sense, right? It's the closest body to us. We've been there before, so we kind of understand the science. And it really is a place where we can conduct good science to help us learn more about deep space exploration and kind of give us that step to be able to push ourselves to go on to Mars. So it just makes perfect sense. And it was a few years ago that the Lunar Reconnaissance Orbiter discovered that there's ice water on Mars or on the moon. So obviously, and not just that, it discovered that there's like 22% of the surface material on the moon is made up of ice. So it's there, and we get to go and really seek it out and use it as a resource, as a few resources, and also help us with moving on to the next step, which is Mars. And so it will be done geology, systems will be tested, technology, new supplies, and really put together new international partnerships and really push ourselves as humans to accomplish this amazing, really complicated but exciting new goal. And so it's very exciting to be able to know that this is happening soon. Where are we going? that LRO discovered that the ice is existent in craters inside of the craters that have never seen sunlight. So this is a little video of Shackleton craters. You can see it gets sunlight all the time, but inside the craters, they don't ever get direct sunlight. So ice is stored deep down in those craters. And that's basically where they want to go. And that's near the South Pole. And so before in Apollo, we were in the middle of the moon. It was safe. It was where, you know, we thought was the safest place for that, you know, the first steps of going there. But this is going to be a next level, going more to the South Pole and seeking out that ice that's there, you know, that's proven to be there. It's a different kind of mission. And the mission really, it dictates the design of the components of going there, right? So we've done low Earth orbits, which is the International Space Station, low Earth travel and living in the International Space Station. And when that's 250 miles above the Earth, and it's going at a speed of 17,000 miles per hour. And so going and coming back, we've been doing that for 20 years. It's a 3-hour return. And it's just, we've become so familiar with it. Going to the moon is a little bit different. We've done it. We know that we can do it. The science is there. The orbits are there. The trajectories are there. But there's still challenges. You got a 3-day return. It's a 7-day trip to the moon. A 3-day return, you're coming in at faster speeds, and it's a larger distance, and therefore the heat shield, it's a lot harder to enter humans back into the Earth. And so that you develop your design based on these statistics. And obviously it prepares us to prepare ourselves for Mars. Mars is a 9 to 10th month journey, longer distance, and you're coming in at a faster speed. So all these things, scientists and engineers are looking at these factors to help them develop a good design for their spacecrafts. And speaking of which, now we look at the different components of the Artemis missions. Right now, the biggest component is the Space Launch System, which is the rocket ship here, and it's really been a component that's really been driving them. They've been working on it for quite a few years now, and it's awesome to say that they're almost there. We are really excited. Actually, you'll get to see pictures soon, but basically, this thing is huge. And it's composed of the booster, which is kind of similar to the space shuttle boosters. And then you got the 4 engines, and then the core stage. And look at the core stage. Look how big that is. That is basically your fuel tank. It takes so much fuel to get yourself to the moon. And that's basically the size of what it needs to have all that fuel in there. And then you got the upper stage and adapters. And so all these components get stacked together into our rocket. And there it is. There's your comparison. You have the Statue of Liberty. If you've gone there, it's 305 feet. And then you got the Orion Block 1, which is the rocket ship that's going to be for the earlier Artemis missions to the moon. That's 322 feet. So it's larger than your space shuttle, larger than your Statue of Liberty. The Saturn V rocket, which is what took Apollo onto the moon, is larger. That's 363 feet. The Orion Block 2, which is the one that's going to be taking humans to Mars, that's going to be around the Saturn V. So we got a good size rocket ship that's going to be able to really push humans onto the moon. That thing is big, like I said, 322 feet, and it's about 5.75 million pounds. So it's pretty big. And it has, that's what it has, the Orion spacecraft on top of it, right above that core booster and the adapter, and the adapter is up there. And so that's where the Orion is, up on top, right under the abort launch system. Orion kind of looks like your spacecraft from Apollo. It's the same physics, just obviously updated to the 21st century. And so here you have it. This is what sits on top of the Saturn or of the SLS. And you have the crew module, which again looks similar to the command module in Apollo, but it's a little bit different in a sense of, like, obviously it's updated. The command module in Apollo fit 3 people for up to 13 days. This one fits 4 crew members for up to 21 days, 30% more volume. So it's for more crew members, obviously. And then you have your service module. That's the heart of the system right here. That's where your energy is, your electricity, your heat, your water supply, your oxygen tank, and all of those. And then you have your abort launch system. That's, if needed for first 2 minutes of the launch, that's able to take the crew out of the spaceship and land them safely if there is an emergency. Obviously that was developed for Apollo as well. So some similar technology, but updated. This thing is going to have updated technology, obviously cameras everywhere. So it really is something that they've been working on for many, many years, and they've tested so well. And so now we have all the components, those components of the rocket ship coming together. The next component we have is the Exploration Ground System, which is at Kennedy, NASA's Kennedy Space Center in Florida. And if you've been there, you've seen the VAB. What a huge, amazing building it is. One of the largest in the world of its size, like open space buildings. And that's where they assemble the rocket. They assemble all the parts on top of each other. They all arrive at different times. And basically, they assemble them inside of there. They did the same thing with Apollo. And so when you assemble them together, they roll it out from there. And so the Kennedy Space Center has also been updated. They're still using pretty much similar to a lot of things from before, but it has also been updated to the new technologies and the new communication systems. And also the center itself from outside of the web has been, they've added on to allow commercial companies to come and be part of it, because Kennedy Space Center is really a spaceport. It really is America's spaceport. And it's funny, when you go there, they tell you like pad 39A is the only place on Earth where a human left it and then landed on another planetary body. So really what an amazing place, really, it truly is a spaceport. The Space Launch System arrived at Kennedy Space Center in April 2021, and then Orion arrived there in October 2021. And right now, as of now, these are a little bit older pictures, but basically they've stacked them on top of each other. You got here the core stage with the boosters and the adapter, and then you have the launch abort system with Orion right under it. And then they stacked them on top of each other. And there you have it. This is the most updated place we are right now. This is according to their Facebook page as of a couple weeks ago, or maybe a week ago. I think the picture is a week ago, and then the checklist is a couple weeks ago. So yeah, this is where we are. It's attached to the mobile launcher, and basically they will take it out of the VAB, and then after all these tests are done, so they still got 4 more things to test out. Once they're done with those tests, then we'll be able to roll it out onto the launch pad 39A. And then from there, they will do a wet dress rehearsal. So it's really exciting, you guys. We're really almost there. It's actually really exciting. This is a view. And by the way, I was going to say this before, all of these images this is a NASA presentation, so image credits all of it to NASA. So this is back in 2018 when they were working on the mobile launcher. Right here, as you can see, is attached to the crawler, and that crawler is the same one. This was built in 1965, the same one that took the Saturn V onto launch pad 39A. And this thing is huge. It's the size of a baseball field, and it carries 18 million pounds. So it's really a big thing. And it moves so slowly, literally crawls 1 mile per hour and slowly gets to launch pad 39A. And this is the artist's conception of basically the rocket ship will go from the VAB and then onto the launch pad, and from there onto the moon. So it's really exciting. So basically we're waiting, the rocket ship right now is inside the VAB. We're waiting for it to be transported on the crawler onto launch pad 39A. And right now they are saying that their launch date, they're targeting it for March. So no earlier than March. Once the rocket ship is on the launch pad, they're going to do the test, a wet dress rehearsal. They're going to fuel it. They're going to test everything that they could before launch. And once that's ready, once that's complete, then NASA will announce a launch date for Artemis 1, which is so exciting. They're looking at April to May. So sometime between April and May, if everything goes well, then Artemis 1 will be ready for liftoff. So all the folks at Florida are really lucky to be able to there. Once again, a huge rocket ship will make an earthquake down there and they'll send them off to the moon. So that's really exciting. And Artemis 1 is basically a chance for, kind of like what Dee said, engineers, they test different parts of the spacecraft and of the different, materials and components. But it's like, this is the part where they test it all together. This is the part, and Artemis 1 has no people. So basically they're sending all of this to the moon and back with nobody in there, but they actually have dummies inside of the Orion because the dummies will be censored. And so they actually test like the pressure, how it is on them. It's just tests, a lot of tests, and basically making sure the communication system works. Everything is just flawless. And then the heat shield, and then the parachutes, because they're able to test those here, but to be able to test it as a full component, a full one system, they could only do it by sending it to the moon and bringing it back, because those speeds only come by going to the moon and coming back. That heat is only, it only appears, it only happens as the spacecraft Orion is entering the Earth's atmosphere. So they've tested even retrieving Orion from the ocean, but to be able to test it after it comes back, that's all going to be part of Artemis 1. So that's really exciting. Like I said, no earlier than March for the dress rehearsal, and no earlier than April, May for actually launching it. Artemis 2 is our Apollo 8. So for those of you who remember, Apollo 8 was the first time humans went to the moon and came back. It was when the astronauts saw the Earth rise, you know, so that's what we get to see. Our generation, you know, the Artemis generation gets to see the new generation Earth rise. It's Orion going around the moon and coming back with the crew. There will be 4 crew members on Artemis 2. I said Artemis 1, I didn't mention this, but Artemis 1 will be a long trip. It will be like between 26 and 42 days, lots of tests. The Orion will go around the moon multiple times. They will be testing the heck out of it. Artemis 1 will be shorter, or Artemis, sorry, 2 will be shorter. It will be up to 8 days, but can go minimum 8 days, but can go up to 21 days. So 4 crew members will go and they will circle the moon and do more tests and just make sure that the spacecraft can handle them, and they just, you know, they're gonna test everything. They'll really test everything, but this will be the part where it'll be like a human presence inside the spacecraft. They'll be able to take the pictures and see the Earth rise, and so for them to be able to do that, that's going to be exciting. And so Artemis 2 is scheduled. They don't have a date yet for it, but right now they're saying no earlier. So 2024 or later. They don't have an earlier date, obviously. So there's still some time. The goal was to land humans on the moon by 2024, but you know, they're working hard. They really, at every session, they remind us that they're working their hardest. But Artemis 2 will be 2024, and then Artemis 3 afterwards. So here's some astronauts at Kennedy Johnson Space Center in Houston inside the Orion spacecraft. As you could see, there's 4 crew members. And basically the spacecraft is just modern technology. I mean, even the lighting is there to simulate day and night. That way the astronauts don't mess up their circadian rhythm. And yeah, they'll have one sunrise and one sunset to be able to, you know, manage that as well. So that's really cool there. These are your astronauts. These are your Artemis generation astronauts. So the way it works is that NASA doesn't select their crew members, their flight crew members, up until 2 years before the flight. So these astronauts are part of a pool that they get to choose 4 of them to go on Artemis 2. So if we said Artemis 2 was in 2024, we're looking at 2022. This year is when NASA will select astronauts from this team, 4 of them to be part of Artemis 2. And so it's really exciting. You probably may recognize some of these faces because they're all active astronauts. They're working. Some of them have gone to the space station. They've come back. So it's really exciting to see just the diversity and just being able to see all these women on here. It's so exciting. 4 of them will be part of Artemis 2. Obviously, they'll have international partners for the future Artemis generations missions. But for now, the Artemis 2 and then Artemis 3 for the first humans to land on the moon, I believe will also be picked from this team as well. Artemis 3 will be our Apollo 11 moment. This is the moment where NASA will send the first woman and the next person, you know, next man or person of color onto the moon. And so how exciting, really how exciting that we'll be able to witness this within the next couple years, with the next few years. So probably they don't have a date. They wouldn't give us a timeline for this, but Artemis 3 comes after Artemis 2. So if those tests and everything works out good, we got our first humans back on the moon. And the way this is going to work, so Artemis 3 is going to be humans will go, so there'll be 4 crew members onto Orion. 2 of them will stay in Orion and orbit around the Earth, or the moon, just like they did in Apollo, and then 2 will go down in the human launch system. And so the human launch system is NASA has contracted with SpaceX to just provide the launch system, the human landing system. I'm sorry about that. Human landing system. This is only going to be for Artemis 3. Okay, so not for Artemis 4 or 5. Those will be developed probably. They don't know yet with who, but basically SpaceX is doing their initial landing on the moon to send those 2 members onto the moon. And basically those astronauts will be on the moon for up to 6.5 days, do like 4 to 5 moonwalks, and then eventually go back up to Orion and then come back on Earth. So that's the human landing system. And SpaceX will have the chance to basically do an uncrew landing of their system, their habitat there. and then a crewed one, which would be for Artemis 3. So that's something that they're developing, and I believe they're supposed to give us the timeline of their development this year. So looking out for that too as well. 2022 is going to be an exciting year. And then the final component, or just one of the final components, is Gateway, which is really not a final, because Gateway is kind of like the International Space Station. It is going to be a lunar post, a lunar outpost. Basically, they're going to launch it. Eventually, after Artemis 3, Artemis 4, would they start launching Gateway. And basically what it would mean is Orion would come from the Earth, and it would dock with Gateway. And then from Gateway, they would dock it down, land on the moon, and then they would, with the different, like the landing system, and then they would bring it back up to Gateway, and then back into Orion, and then back on Earth. So this is going to be a lunar outpost. It's going to be there. It's going to, just as the International Space Station orbited the Earth, Gateway will continue to orbit the moon and provide kind of like that connection between the moon and the Earth. And it's just supposed to make this process easier to a certain extent, right? The communication, the fueling, and all of that, it's supposed to be there. And this is also, you know, for the long term of going on to Mars, it's supposed to help with that as well. So that's your Gateway. Here's your Artemis base camp. This is basically your astronauts working on the moon. And just, this is really testing everything all together. You're on the moon, you're away from the Earth, you're in a harsh environment. You really have to use your skills, everything that you've learned on Earth, to just implement everything, and everything needs to be implemented perfectly, because you got any problems that come up, you got to figure it out on your own. And so this is the perfect example to do this, because you're so close. Like the moon is so close, Mars is so far. If they go to Mars, it's like astronauts are there for a month, and then they come back. It's just such a long trip. But the moon it's decent. It's not too far out. So it's a perfect way to kind of push ourselves to learn, and study, and do research, and then kind of take that and learn and use it to kind of push ourselves to go out to Mars. So that's really exciting. You got, the space suits, testing out the space suits, and then the habitats, and just being able to kind of know how to work out there. And the thing is that where is the space camp? Like I said, we want to go to the South Pole where the ice is, but they also need a place. They haven't chosen a base camp yet, but they will need to find a place that has near continuous sunlight for like temperature purposes, and then also energy purposes for the solar power. And then also they need a place that has easy access. So, and then you got commercial companies that are going to be working with NASA to provide them with like the rovers and the habitats and just all these things. So really it's a huge effort. It's really a huge effort, and just so many job opportunities, partnerships, just understanding, just working together as just a human race to get people on the moon. So exciting to be able to see that kind of like unity, and really just inspiring a new generation to go into these careers of like STEM. So here we are. I love these maps, these kind of flight plans. So I'm not going to go too much detail, just kind of give you an idea. You got your Artemis 1 flight plan, like I said, going around the moon and coming back, no crew. This one can take up to 42 days, so 26 to 42 days, lots and lots and lots of testing. And then we have the Artemis 2, you got your 4 crew members, and they will be doing their Apollo 8 kind of thing, where they're going around the moon, they see the Earth rise, and then they come back to Earth. And then that will prepare them for Artemis 3. And this is how NASA works, right? They do things in stages. That's what Apollo was. It was stages, right? And so it's the same idea. You just got new technology. You got to make sure you test it properly and kind of take it up in stages. So there you have Artemis 3 landing on the moon. And that's going to be with a human landing system. And so that's going to land you on the moon and then bring you back with Orion as well. And then you got the Artemis 4, and that's going to be setting up Gateway and kind of getting Orion to kind of get Gateway into there, and kind of getting Gateway into the picture. That's obviously a lot of people are working on that, but still a lot of those details aren't really finalized yet, so things can change. And then you got Artemis 5, and this is when Gateway continues to be built, and then we continue to use Gateway to land back on the moon and come back out. And so really a full system is being created to kind of make this space exploration something that's of the norm, really. And that's it. Really looking forward to all of this. It's really an exciting time to be part of, interested and into space exploration. So keep an eye out for all these exciting new timelines.
Awesome. Thank you, Nadia. The audience audience questions have been coming in fast and furious. So we'll take a moment just to ask one or two while we have you here, and then we'll bring back all of our other panelists.
Okay.
So Phil and Cindy, so thank you for this awesome presentation and giving us a lot to look forward to in the decades ahead. Phil and Cindy asked why is the human landing system, HLS, so much larger than the Apollo lunar landing module? How much of it will remain on the moon?
Oh my God, that's such a good question. And I think those are details. I don't know if that's exactly what it's going to look like. That's a SpaceX thing. And not much detail has come out of that. That's their concept, but I don't know if that will change. So definitely something I was told that the development will come out this year. So definitely something to look into. I don't know. I don't have the full answer for that. But it will be interesting to see their design and their final kind of like thing of what they do come up with. But
Gotcha.
it's supposed to last longer. If you think about it, Apollo they were on the moon for just a few hours the first couple times. Then eventually just, I think the most was like a day. So this is supposed to give crew members the ability to stay on the moon for at least 6.5 days. So obviously it just needs to be longer, it needs to be able to hold them for that long.
Got it. Another question I had you in the beginning of your presentation, maybe if you could stop sharing your screen so folks can see a little better. At the beginning, I think you're still sharing. So just there we go. Got it. At the beginning of your presentation, you were talking about the presence of ice on the moon. Yes. And I'm wondering, how was that discovered in the first place? And then I have a follow-up question from one of our audience members.
Oh, yeah. So oh my God, I had the details and then I have a mom brain, so I forgot exactly. So don't take me on the dates. But basically, a few years ago, NASA basically crashed a spacecraft into the moon, and then another spacecraft, which is probably LRO, went into it.
Can you say what LRO is? Because our audience may not know what that means.
The Lunar Reconnaissance Orbiter is currently, going around the moon, and it's analyzing it and kind of, mapping it out. And through that, they were able to detect ice and water. And so from that, they realized that it's there. That is the extent of it. I'm gonna bring in Chris. I'll allow Chris and Dee to add if they had.
Okay. We'll ask them.
Yeah, that's when we discovered that there was ice water on the moon. So
the follow-up question is that Miles was wondering if there is water. Are we looking for any signs of life on the moon, or has anyone ever looked for signs of life on the moon?
Right. So due to like the fact that there's no atmosphere and there's solar radiation, life is non-existent as of now. It's different than Mars. Mars it was in the past, it had an atmosphere, so life may have existed. But with the moon, it's just so different. And so it's a history book, but not a live one. So there's they don't think that there was ever life on there. It's just there's ice, so that would be perfect to kind of use as a resource.
Great. All right, let's bring back Chris and Dee to join us, and I'll change the audience's view too, so that they can see the gallery of all of our wonderful NASA Solar System ambassadors. So thank you for joining us. Did any of you all want to have a comments about Nadia, you wanted input? I forget. See, I got a mom brain too.
Yeah. The ice, was it? Did they map it? Did they map it, or was it through that experience where they crashed something and then that
yeah.
through it? Is that
you had it right. There was a spacecraft, and then its booster was purposely crashed so that the satellite could image and do spectroscopy on everything that got kicked up, and they verified that there was ice. Which was theorized, and they got verification that, and then they could do the volumes of how much was in there based on what got kicked up.
Yeah.
So
the only reason that ice is there because the sun shines on all sides of the moon. There is no dark side of the moon. They all have dark and light sides, just like Earth. But these craters are so deep that there are some places on the moon that are actually always in shadow. So even when the sun is shining over that part of the moon, there's shadow there. And like you said, Nadia, there's no atmosphere. So it's cold. It's colder than Minnesota.
Right. And I was reading, that's true, because I was reading that in some places it's probably one of the coldest places in the solar system because there's no sunlight there. So definitely a challenge. How do we get the ice, and how do we, how do we protect ourselves from all that cold, right?
Yes.
And why do we care about ice in the first place? Like, what are we going to use that ice?
Right, right. Yep. It will help you. It's hard to carry all that material up to the moon, the fuel and the water. And so they'll be able to use that to create that. They'll be able to use that resource and then eventually onto Mars.
Yeah, because if you got ice, you've got water for drinking. You can split it for oxygen for breathing. You can turn it into rocket fuel. It's liquid oxygen is one of the main components for that big SLS rocket that was shown. For going up. So yeah, if you find ice, you can make all these things to help you live there, stay there, make your fuel for coming back, so you don't have to bring it all with you. So it cuts down on the amount of things you can bring to the moon, because you don't have to bring all that extra fuel with you for the return trip. So it's a game changer if you can process ice.
So like they said, it's ice water, which gives you hydrogen and oxygen. So there's some elements we can use. Awesome, guys.
That's awesome. All right. Well, maybe we'll keep, just because we're on the moon. I got Mars questions. We from the audience. We'll get to Mars, but since we're on the moon, we'll stick with it. Sure. Phil and Cindy asked, when Neil and Buzz blasted off from the moon to return to the command module, did their footprints get blown away by the rocket blast?
Oh my God.
No, they did not. And what did get blown away was the flag. They put the flag too close to their ascent vehicle. And honestly, again, remember, there's no air. So it's only that, puff or whatever, the energy that comes from the vehicle. And it was just enough to knock the flag over. So on the next mission, they got that flag parked over where it wouldn't get knocked over.
That's funny. I didn't know that.
One thing I tell all the kids too for presentations on the moon is that the flags from all the other landing sites that were placed far enough away so they're still standing, that if you were able to go visit, you wouldn't see the stars and stripes. They've all been bleached white, from all that ultraviolet. So it would be like a white piece of fabric. It wouldn't look like the flag that we saw in all those great photos that they were taking. So I tell kids, some kids have had experience with that. If you've left out an article of clothing, or you have a flag and it's been out for several summers, it gets faded from all that, UV light. And so it just happens that much more intensely on the moon. So they don't look like the stars and stripes anymore.
Yeah. I saw pictures yesterday. Stacy Tiedekin in her presentation showed some images from the Lunar Reconnaissance Orbiter, and you could see tracks from some of the rover vehicles, and because it did pass bys of previous landing sites, which was pretty neat to see. Still there as well. Okay, this next question about the moon, I love it because it brings together two big things. Meg asked, depending upon the time for the mission, so this is all depending on timing, would Artemis 2 be able to see the moon shadow for the 2024 total solar eclipse of the moon? So that for our audience, the next total solar eclipse visible in the US will be April 8th, 2024. I feel like this is a very meta question. And so you are our experts. I'm gonna let you answer that one.
I mean, if you're at the right place at the right time, I imagine, yes, you should be able to see a shadow. Yeah.
Dee's thinking.
I think it's actually a great one to throw out to all of you students of math. Calculate it. You can calculate the orbit. You can calculate the timing. We do have to have some information of when we're launching and when we're orbiting. Right. And we certainly could calculate that and decide if they would be able to see it.
Yeah.
Well, and to jump off of that too, with the calculations, that's another big thing on moon presentations that I talk about, is that there's a 2-week lunar day and a 2-week lunar night. And the engineers and scientists are even really concerned about the angle of the sun in the sky for the astronauts, walking around, so that they can see things for coming in for landing, in good detail and all that. So they get it down to, where is the sun going to be in the sky? It's not just a random, we're going on this day. They do all the math and calculations to figure out, we want to go during a lunar day cycle, obviously, and we want the sun to be at a certain point in the sky so they can be very successful in their field operations.
Well, it's kind of like what Dee said about those bolts. Like they really look at every single component. You never think it's really, they're perfectionists. Those engineers are perfectionists. They ask every question possible.
Great. Okay. We're going to move to Mars. Just
All
so I
right.
can be, I don't want to make sure that Mars doesn't get the short shrift like this guy cranked it. Curtis asked, has Perseverance, and I'll back it up and say like Curiosity too, have they ever experienced a Martian dust storm? And did that have any consequences?
I know for sure that the rovers we sent before that did, and those were the twin rovers. And they experienced many dust devils. And actually, it was a good thing because the dust devils cleaned the dust off of the solar panels. And so they actually had a higher rate of collection, battery charging after the little dust devils went by. So I do believe that Curiosity for sure, and I don't know about Perseverance, have at least experienced that. And remember, these storms, the winds, when they blow, like I said, 100 miles an hour, and your hair wouldn't even move. So basically, it's just lifting the dust up off the planet, and it looks quite spectacular, but it's not as, scary for the machinery, except for if it collects the dust. And that was what they were worried about in the first place. But it looks like the storms might clean the dust, which is pretty interesting.
Yeah. Jefferson asked the question, and I wonder if it's inspired by, there's a children's book, a children's picture book. The First Kid on Mars is the name of the children's picture book. Jefferson asked, are there plans for a Mars plane? Because that book shows one.
A Mars what? I didn't quite
A
understand.
Mars plane. We talked about helicopters. Is there going to be like a plane?
Sorry. Yes, actually they have discussed Mars planes. And they started with the helicopter because you can, kind of generate that lift that you need with the helicopter, but they are actually looking at gliders first and hopefully powered type planes, at least to take cameras around. I don't know eventually if that would carry humans or not, but that has been discussed.
Awesome. Miles asked, and I know this was a great discussion when Perseverance landed, what does the pattern on Perseverance, on the parachutes that are landing these rovers, mean anything?
Yeah, I actually saw that question. I pulled up an image on my phone I can share. So it's a binary code. And if you can see that, it says, dare mighty things is what it spells out. So that's a big saying at the Jet Propulsion Laboratory. And so you can find that on the internet if you just want to Google it, but it shows a picture of the parachute. And then those colors, the alternating, the red and the white, is kind of a binary code system. And so if you have a little chart on what the numbers mean, you spell out, it says dare mighty things on it. And then the very outer ring actually has the GPS coordinates for the Jet Propulsion Laboratory in Pasadena, California, where they built the rover. So
are there always messages encoded in parachutes, or was this a new thing?
JPL has a history of doing a lot of that. Actually, on the Curiosity, on some of the rover tires before, they put in a code when it would drive and make a mark, in the sand. It was doing the same thing. So that they're big on that. There's a lot of Easter eggs on the rover as well for different things.
The wheels were coded in Morse code with JPL.
Yeah.
And they don't just do it this is sort of the secondary function. They did want those holes in the wheel, we'll call them, because they use that to measure as the rovers went forward and backwards to see how they were doing. So they left those prints. And the same with the parachute. They don't just put things on parachutes without them having function also. But isn't that creative? That's what I'm talking about when you're engineering, to add your personal creativity to the actual function of the thing that you're doing.
Yeah,
Pretty
that's
neat.
awesome. That's very cool. All right, I want to switch in the last few moments we have left. I'd love to switch gears and talk about you, and talk about your path to becoming solar system ambassadors. I think that you all probably have some curious backstories, and so it would be really neat for our audience to learn. One, how did you become a solar system ambassador, and then what inspired your interest in space and astronomy? We can go round robin. I don't know. Chris, I'm going to pick you first.
Okay. I was like all those pictures Nadia showed of the original Apollo astronauts. I had all their photographs on my walls as a kid, and I very much wanted to be an astronaut. My dad was a private pilot. I went to space camp a couple of times as a kid, and then I got to be too tall. I'm almost 6'5", and that's over the height limit for that. So I was very depressed, crying in my pillow, but found over the years ways to channel that energy, that passion I had for things. And when STEM became a big buzzword, my kids were kind of bringing back these boring photocopied sheets of activities. And I was like, well, I could do a cooler thing based on, my experiences at space camp and all that, do some demonstrations or something. And I did it as a one-off kind of, what does your dad do at work kind of day. And then I had teachers stopping me in the hallway going, my kids are still talking about that, 6 months later, what are you doing next year? And I'm like, oh, I didn't know I was doing next year. That was just a thing for the STEM day or whatever. And it kind of just built momentum. And so that led me to setting it up as a STEM educational nonprofit here in Hudson, Wisconsin. So I see all the schools and Boy Scouts and Girl Scouts and libraries. And then that was all kind of focused in Hudson. And I started getting requests from outside in Minnesota and other parts of Wisconsin, requests for me to do a program. And I didn't want to take away from the people that were donating, money to my nonprofit. It was meant that it was all going back into Hudson programs. So that's when I heard about the NASA Solar System Ambassador program. I thought, oh, this would be great, because then I could fulfill all those requests from the outside areas under the NASA Solar System Ambassador program. So I applied for that and did the interview and got accepted. And so that's Space St. Croix is all Hudson, and then anywhere outside of Hudson like this is under the NASA Solar System Ambassador banner.
Awesome. Nadia, what about you?
Well, I was going to say, Chris, it's interesting because I was reading about Orion. It was like, it should fit like 99% of like the human population. I didn't understand that comment or that statement. And then it said, humans that are as short as 4'6" and as tall as 6'5". So
yeah,
do you live like, are you above that? Are you in the limit?
yeah. I was rated. Well, and they've raised it now. When I was a kid, I think the cutoff was like 6'3" when I was, so, because you have to fit in the capsule and fit in the spacesuits and all that. So I was getting too tall for that.
So that like now it just hit me with that statement. But perfect.
Yeah.
It makes sense now.
Yeah.
I love it. That's really interesting. I guess for me, I've always loved space, like you kind of mentioned in the beginning. And then I think I remember when I was young, we watched Apollo 13, and then I loved NASA. Like, wow, like they can do that. Like they can bring humans that are like in a spacecraft that's dying back home. So I always just loved that, just that drive and that ambition to explore the unknown. And I also love all the sciences. I have the passion for just like the earth sciences and just all of it. And it never faded away. And I didn't really do anything. I went to school. I went to the U of M for astrophysics, and I didn't really do anything after that. And then one time I was just scrolling through social media while I was nursing my newborn, and it was like, apply to be a solar system ambassador. I was like, what is this? And I looked into it, and it was like, all you got to do is this, and you get to go and talk to people about space. Like, what? And you could be part of NASA. Like, wow, that's so awesome. And so I applied and I interviewed and I got it. And it's just been so much fun. I got it before COVID, which I was able to do a year of stuff, and then took a break. But it's good to be back. It's good to be back and to be able to do these talks again.
Dee, tell us your story.
Well, my story is this, that when I was young, we had a thing called a television, and my parents put me in front of the television to watch this guy land on the moon and walk on the moon. And I was like, they look like ghosts up there. There's just black and white and kind of interesting, but I was like, that was amazing. And I turned around and I announced to my family that someday we would be probably taking a vacation to the moon with my grandkids. And I would turn around and say, hey, I saw the first guy step on the moon. Well, guess what? We're not there yet. And so but I have 16 grandkids. And when we celebrated the 50th anniversary, I turned around and said to all of them, hey, I saw that guy step on the moon. Well, I went on to be a teacher. I went to the University of Minnesota. And then I wanted to have my students be involved with something that was career oriented and hands-on and not just textbook. Guess what? The Bell Museum had it. They had something called the Jason Project. So I got involved, and through the Jason Project, they were doing something called the Stardust Mission. Stardust Mission was looking for educators to apply and promote the Stardust Mission through teacher education and so on. I applied and I got selected. And not only was I a Stardust educator, but went on to be the Solar System Ambassador since 1999. So really, it's you guys, the Bell Museum, who made it all possible for me. Thank you very much.
Oh, that's very good. I honestly didn't plan that question with that in mind. I thought that our audience might be interested in learning about your backstories and learning how they might get involved as a NASA Solar System Ambassador. And I think I saw online that applications are due every September. Is that right? That I think I saw
around that time. Yeah, around that time they open up
Google NASA Solar System Ambassador. Well, it's hard to believe, but we've been talking for 90 minutes. And so I could keep going, but I think that we should wrap it up. And I just want to thank you all and thank our audience. There are so many awesome questions. We didn't get to answer them all today, but I'll make sure our speakers all get to see how engaged and excited you were. So again, thank you to our NASA Solar System Ambassadors, Chris Mick, Dee McLellan, and Nadia Abuisnaineh for being our special Space Fest guests today. I'm going to share my screen real fast here so folks can see. There we go. And tell our audience that while sadly our official Space Fest 2022 virtual programs have now officially wrapped, please do check out our Space Fest website for resources and activities to keep the party going. We'll also be posting a YouTube playlist of our recorded talks, including today's program and yesterday's program and Friday's virtual Star Party. So you can check out those links to Space Fest 2022 resources, recordings, and more by looking at z.umn.edu/spacefest2022. Let's see. I'm trying to do one woman operation here with my slides. Finally, I'd also like to note that the events of Space Fest 2022 are part of the Bell Museum's 150th anniversary celebration. Thank you to our 150th anniversary sponsors, especially our presenting sponsor, General Mills, for making this a truly exciting year for the Bell Museum. Finally, we also want to thank Ruth and John Huss for their continued support of the Bell's Minnesota Astronomy Classroom programming. That's a wrap. Thank you, everyone. Take care. Have a great Sunday. Bye.